Hey, what is up guys? Welcome to my first ever YouTube video. Today's topic, I'll be looking at how to calculate conversion rates in R. In this video, you'll see me use different R libraries to not only calculate conversion rates, but also explore some other notable marketing KPIs. So let me give a little background. The dataset that I have and that I'm working with is one I obtained from Kaggle.com. If you're not familiar with Kaggle, it's this website with thousands of data sets that you can do a ton of different cool things with. And so I already have the data set downloaded. I have my working directory set up to that folder destination. And so with any project, I like to start out with defining my goals. And so for this data set, it focuses on social media campaign data. And so I have a primary goal, and I like to also have secondary goals. My primary goal is to identify the social media campaign that effectively converted the most customers. My secondary goals are to measure the performance of ads and campaigns. Additionally, I want to visualize nominal trends in regard to each campaign by age group. I also want to calculate descriptive KPIs to measure the success of each campaign. And this includes the conversion rates, click-through rates, customer acquisition cost, etc. And lastly, kind of for fun, I want to identify if there's any correlative relationships between variables. So how I like to set up my R work or R projects is by commenting well, obviously, but also with all my libraries at the top so I know what it is that I'm pulling in. And so what I'm gonna do is, comment out just my library section, kind of defining this section as where I bring in my libraries. The big one is tidyverse, so I'm gonna call in tidyverse. I'm also going to call in janitor, and this is a package that helps me clean my data. Very helpful, and also creating frequency tables, stuff like that. And then lastly, for that little fun analysis, or more so quick view, I'm gonna call in core plot. Cool. And if you guys have any questions on any of these packages, feel free to leave a comment and I can answer and let you know what it is they do and use cases for them. And now that I have my packages up on the top, there's also a ton of different things that I need to do before I begin my analysis. And so I don't know if this is something common on just my machine, but I don't like to have scientific notation in my projects. And so I want to remove the scientific notation. I'll do this by this little command. And there's a ton of other things I also need to do, but I want to ingest my data set. And so let me call this for my working directory. And again, I'll label this. It's very important to label things because it's easy to kind of lose track of where stuff is with all the lines of code. If you're like, what the heck is a tibble? I'm right there with you because I have no idea. I'm just kidding. It's like a fancier data frame. I think it's more like new age data frame. So use it if you want. And read CSV. I want to call the name of my data set, and it's called CAG_conversion _data .csv. Let me run that and ingest it. Perfect. And let me turn that into a tibble. Did I say table earlier? Don't know, but tibble, and it is my data object. Cool. Cannot find function tibble. Okay, let me, I never ran my library, so that's probably the issue. Bada bing, bada boom, and then execute this. Boom, I have a tibble. Perfect. So now that I've ingested my data set and it's in my environment, I like to always, when I'm starting a project, is kind of just quick view my data. And so I'm just going to label this section quick view. And it's to understand the format of the data. Numeric, character, integer data. I kind of want to know how columns are read in. Structure data. This is one method. Gives you a quick view of the different columns, their column names, and also what type of kind of data type they are. So this is integer, age is character, gender is character, spent is numeric. But there's another function that's helpful, and it's glimpse. I think it's just like a cleaner way to look at stuff. And then if you kind of just want to get a summary of your data, you can use summary data. And this kind of works the best, really, only for like numeric data and integer data. And so obviously you can see for gender, it was a characteristic, doesn't work. And then age was a character as well. But for stuff that can be incremented, like interest, impressions, clicks, and spent, you can kind of see that the max amount of clicks per ad was 421. You can see the max impressions per ad was at 3,052,003. And it just gives you a quick overview of the different numerical columns in your data set. So now that I have this, again, I like to use, like I said, I like to use my top section to kind of centralize my libraries. I read in my data, quickly understand my data. But I also, if you're working with data that you might not be so accustomed to, I also like to create a data dictionary. And so each column represents a different item. And so instead of, making you guys wait while I type everything in, I'm just gonna grab it real quick. Boom. So that we got the setup out of the way, we can kind of dive into what it is we're going to analyze. And so with analytics, there's 4 big buckets of analytics, and this includes descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So from the top down, descriptive, answers the question of what happened. Diagnostic, why did this happen? Predictive, what might happen in the future? And prescriptive, what should we do next? And so I always like to get a good sense of my data, maybe sum it up by the count of items, create different sorts of visualizations. If I'm not sure what I want to do, I oftentimes reference our cheat sheets, and those are available in, I believe, the help section. Yeah, cheat sheets. These are handy if you want to get a better sense of what you might need to do with the data at hand. But let me begin by going into exploratory data analysis, which is essentially a component of descriptive analytics. And so I'm just going to label this 2.1 EDA, short for exploratory data analysis. Let me just space all of this. I have room. And what I'm going to do is I'm going to create frequency tables for items in my data set. It's pretty much just an overview. And how will I create these? So there's actually a function called table, and it's from the janitor package. And so you can do 1-way, 2-way, or 3-way tables. And so I'll go through one example of each. So table, I want to bring in my data tibble. It was a data frame, now it's a tibble. Remember, we changed it early on in the process. And I want to look at my total conversion. and I'll use a pipe operator, arrange by descending percent, and let's run this. And what do we get? So a table, just a frequency table, and this is telling me that 666 or 58.2% of the ads in my data set led to one conversion. Similarly, 162 or 14.1% of the ads in my data set led to 2 conversions, and so forth. So that's an example of a one-way. If you look at a two-way table, I gotta figure out if I should capitalize stuff or just keep everything lowercase. And I'm gonna do this by campaign ID data. I'm gonna, instead of doing the above method, I'll show you guys a different method with this of how to read in the typical data. And I say data and data interchangeably, and I can't just pick one. I feel like I should. Data, table, XYZ, campaign ID, and age. Let's run that. What do we get? We do get a breakdown of the campaign IDs by age group. And so campaign ID 1178 was targeted to a lot more people in general. It was also targeted the most to the age group of 30 to 34 by a little bit. Targeted the most to age groups 35 to 39, the most to, and you get the deal. And lastly, we can do a three-way table. I wonder if it's pronounced table, and I'm just saying table like an idiot. Three-way table, again, by campaign ID, data, table, XYZ, underscore campaign ID. I'll look at it by age and also by gender. Let's run that. Get a better view of this for you guys. And so one interesting thing that three-way tables do is it breaks your analysis into two different lists. So you have your female list and you have your male list here. If I look at it further, let's see. A lot more males were targeted in campaign ID for these age groups than the females at those age groups. I mean, not by a lot, but it's the only thing that's set out. And let me shrink this down. Now that we have like tables out of the way and kind of get an idea of how campaign IDs, I shouldn't call them campaign IDs, I should just call them social media campaigns between different columns of interest, I'll create some visualizations. And so some of the more popular visualizations are bar plots, line plots, box plots, scatter plots. I love scatter plots. But we'll start by creating some bar plots. So let me just comment out that I'm doing that. Create bar plot to identify nominal impact of ads shown to various age groups. But I'm not just creating one, I'm creating multiple. So let's add an S there. And so I'm just gonna call this bar plot D. I should call it B, but I'll call it D. Like Angela in The Office, she's like, oh, D. That's a bad joke. ES, age. And then I'm going to need to visualize that. So visualize or print that. So let's add that to a GM bar. And Let me run the first line. Let me run the second line. And I should get a plot. Perfect. I got age on the X, count on the Y. And this is kind of like another thing that you can use instead of frequency tables. Just kind of gives you the breakdown of ads and how they were shown to these different age groups. Let's create another bar plot. Let's call this F. Yes. And I think let me do age and then impressions. And this is probably a long way to write down all this code, but it's kind of how I did it. Call. You guys want to see the other way of doing it? I mean, same output, but it might be a little cleaner. Just leave a comment and I can direct you into resources that that might help with that, or I can make a video for that. Just let me know. GM call. Oh, I never ran the option PSIPen. You're like, what? The command to remove scientific notation. Let's do that. Let me run this again. And actually, this is a column plot, so it's just adding up the number of impressions per age group. Boom. 30-34 age bracket had the most impressions on aggregate. In second, the 45 through 49 age group. And in the campaigns, they didn't really care for the middle of the packs. Sad. I'm kidding. And then lastly, one variable that works in tandem with impressions is click. And so let's create a bar plot for clicks. So I'll just name this L, and then I'll just do ggplot data, yes, age, and clicks. And then here I'll just do L plus gm call. Okay, age bracket 45 through 49 had the most clicks, and age bracket 30 through 34 had the second most clicks. But what's interesting here is if we go back to our impressions, the first age bracket had the most impressions. But if we go back to the clicks, they had a lower amount of clicks than the 45 through 49 age group. And so already that's telling me that the click-through rate for the older crowd, the 45 to 49, was higher than the click-through rate for the 30-34 age group. Something to know, and super interesting when you're doing analysis like this. And then lastly, what I'll do is, let's see, sum the total impressions of each campaign. And so I've been doing most of the stuff by age, and it's been mainly focusing on just the ads. That's kind of what you've been seeing here. So the sum of the impressions of the total ads, the number of ads directed to the specific age bracket, that has been this stuff here. So now I'll do something by campaign ID, and I'm going to sum my total impressions of each campaign, which will give me a good idea of which campaign generated the most, let's say buzz, but impressions, and then here I'll just call it conversion. You can call it whatever helps you navigate through your project better. And then I'll use a group by XYZ campaign ID. Pipe that into a summarize function, which will sum my column of interest. Impressions equals sum impressions. And let's run that. Object conversion not found. Interesting. Oh, I should just kept this as data. Data, group by the XYZ campaign ID, and then summarize the impressions of each campaign ID. Okay, so the 3 campaign IDs that I'm working with are campaign ID 916, 936, and 1178. And the one with the most impressions was the third one. So this is pretty interesting information to know and can definitely help as you develop the KPIs down the road, which we'll get to in a bit. Another thing I quickly want to look at is the total cost of each campaign. I can't spell today. This will be data, pipe into a group by XYZ campaign ID, quick autofill, pipe into a summarize, and then summarize the spent of each campaign ID. Let's pull that. So total spent for 916 was 150. Total spent for 936 was 2893. And the total amount spent for campaign ID 1178 was $55,662. Sheesh. Hopefully this one had the best conversion rate. It'd be funny if this one did. So speaking of conversion, and I've kind of led on the fact that we're going to talk about KPIs, let's start that. So create some space here. Let me comment out that's the section for the KPI calculations. Calculate. I like lowercase of. We're going to do click-through rate. You can see how many times an impression led to a click, the cost per click. Look at the CPM, cost per mile, cost of 1,000 impressions. We'll look at the customer acquisition cost. And lastly, we'll look at the conversion rate, CR for short. And so let's create the object all KPIs. Just I'm gonna call it KPIs, and it's gonna be from data. And so from data, let's select what it is that we want. Select. And if you're not familiar with the pipes in like the select and summarize and group by, that actually comes from Tidyverse, and more specifically Deployer. So if you have any questions on that, I can send you the reference to that. But if you just type in Deployer in R into Google, it should come up as like the first link, and it has examples for how you can use Deployer in your work process. XYZ campaign ID, impressions, clicks, spent, total conversion, and approved conversion. At this point, if you're like, oh, what's the difference between total conversion and approved conversion? I know I didn't go into super detail, but if you go back to the data dictionary, again, a plus of having this thing, total conversion is the total number of people who inquired about the product. after seeing the ad. Whereas approved conversion is the total number of people who bought the product after seeing the ad. So ideally, we would love approved conversions to be high. Let's go back down. I don't know why I just did that. I don't even need this that much. We have that. Let me pipe that as well. Get to the next line. And then we group by, XYZ. Not that. Campaign ID, pipe into summarize. This is where we're going to summarize the clicks. I think clicks is actually capitalized. Yep. Clicks equals sum of clicks. Approved conversion equals sum of approved conversion. Impressions equals the sum of impressions. Spent equals the sum of spent. And total conversion equals the sum of total conversion. And then we can pipe. So what I'm doing right here is pretty much setting up my, not setting up, I guess I'm creating a new all KPIs object that will help me in facilitating the calculations of the click-through rate, the cost per click, the cost per mile, the customer acquisition cost, and the conversion rate. So summarize and let's mutate. And this is what we really want. Do the click-through rate, and the formula for that would be the clicks over the impressions times 100. Next, we do the cost per click, which is the spent over the clicks. Then we have the CPM, cost per mile. It's not filling, huh? Hopefully I don't come across an error. And then customer acquisition costs, formula for that, spent over approved conversion, there we go. And then conversion rate, approved, let's go conversion over clicks. And then that is good to go. Do I need another comma? I don't think so. All right, let's hope this works. As every coder, programmer, data analyst says, I hope it works. Clicks not found. Okay, we got clicks here, we got clicks here, we got clicks here. We got clicks here, we got clicks here. Oh, I never, wait, no I did. Comma, 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 comma. I think it has all the commas it needs. Let me see. Oh, I think I'd know what I need. See, we have a comma here in summarize. We also need to have a comma in each other item. So comma here, and comma here as it's the last item. I don't think I need this. Now let's run that. Perfect. we have our all KPIs data set. Let's open this up, open this bad boy up. And like I said, it's grouped by campaign ID. We have the clicks, we have the approved conversions, the impressions spent, total conversion. And this is just a sum of what already existed in the data object or data table. And this is the calculations of the CTR, the CPC, the CPM, the customer acquisition cost, CAC, and the conversion rate. And so just looking at this, we can see that the conversion rate for campaign 916 was 21.2%. For campaign 936, it was 9.2%. And if you remember, campaign 1178 was like $55,000. The conversion rate was 2.4%. Not great. Not great. All right, now that we've calculated KPIs, we can look at, I guess for fun, the Diagnostic Analytics. So let me just comment this section out. And to kind of give us some insight on this, I will create a separate object item. So we'll call it diag data. And it's from data pipe to select. And then we'll only look at the numerical column, so impressions, clicks, spent, total conversion, and approved conversions. Execute that. This is my tibble. And now I'll rename my object I'm going to feed into my core plot function. I'll rename it A for Andrew. You can name it whatever you want. Then call core. Then core my tibble. And I like the space. Create a space between here. Execute that. And then we'll call core plot A. And what kind of method do we want? I believe there's a variety of methods we can use. Number, color, and those are the two off the top of my head. But I'll just select number, run this. And we get a nice correlation plot of our variables. And so for example, if we look at the plot here, the correlation coefficient between, let's see, spent and impressions is 0.97. Correlation coefficient between spent and approved conversions is 0.59. So relationship isn't super strong. Again, it's just a little fun side quest. If you're curious about, how to generate a correlation plot, there it is. All right, now that we have everything dialed in, we've met the primary goal and the secondary goals, we can dive into the findings. And so let me create a section for that. Just name it findings. And so findings for the campaigns were campaign, I'm just going to reference it by the campaign number. Campaign 916, the thing that we were looking for the most was conversion rate. Campaign 916 had a conversion rate of 21.2%. That campaign had a click-through rate of 2.3%. And I'm just getting this information from my master data set. So right there. The cost per click CPC was $1.32. The number of impressions for this campaign was 482,925. This number actually was calculated in the sections above. So if I go to the section here, the sum of total impressions of each campaign, and just kind of run that again. Get the impressions by campaign ID, and I'll just keep that handy right there. The CPM, oh, you guys can't see it. I feel like I should create a second row item. Oh, I'm working in the console. It's my bad. But yeah, let me start a new line. It'll be the same. Yeah, the CPM is 31 cents, which is the cost per 1,000 impressions. The total cost of the campaign, again, I'm referencing this from the above section here. Total cost of the campaign was $150. The CAC, otherwise known as the customer acquisition rate, was $2.70. And the total number of people who bought a product was 54. So, I mean, not too shabby, especially considering the conversion rate of 21.2. But let's move on to the other campaigns. This was campaign 936. And just, I'm going to repeat myself for the next two campaigns, so I'll just fast forward with it being done. So now we have the other two campaigns, campaign 936 and campaign 1178. You can kind of start to, compare and contrast these campaigns between another. So campaign 916, 21.2 conversion rate. Second campaign, 9% conversion rate, and campaign 1178 with a 2.4 conversion rate. Obviously, right off the bat, campaign 916 is very strong in converting customers. Campaign 916, click-through rate of 2.3. Campaign 936 with a click-through rate of 2.4. And campaign 1178, the click-through rate of 1.7. Again, most people are being impressed, for lack of better terms, and clicking on the ad, as you can see. But let's dive into the juicy numbers. Number of impressions for 916 was 482,000. For 936, the number of impressions was 8.1 million. And for campaign 1178, the number of impressions was 204 million. That's a lot of impressions. But impressions aren't the kit and caboodle. If we look at the total cost of the campaign, the first campaign cost $150, the second campaign cost about $2,900, and the third campaign cost $55,000. So now let's look at it from a customer acquisition standpoint. The customer acquisition cost for campaign 916 was $2.77. For 936, this customer acquisition cost was $6.23. And lastly, for campaign 1178, the customer acquisition cost was $89.05, which is an outrageous. I mean, out of each of the campaigns, the total number of people who bought a product was 54 from the first, 464 from the second, and 625 from the third. I don't know about you, but it seems like the first campaign was the most effective, strictly off of conversion rate, cost, and the number of people who bought a product. So with that, surface level analysis, we can kind of dive into the diagnostic analytic findings. And I kind of wanted to pick out the most important variables that had, either high correlation coefficients or low correlation coefficients, and also variables that mean something. So clicks and spent. And so in these findings, I found that clicks and impressions had a 0.95 correlation coefficient. Clicks and approved conversions, again, approved conversions are the number of people who not only inquired but also product, had a correlation coefficient of 0.56. Spent in clicks had a very strong relationship, 0.99, and spent in approved conversion had a 0.59 correlation coefficient. And then lastly, we have spent in approved conversion with a 0.59 correlation coefficient. So not the strongest relationship that we would love to see. Now that we have the findings out of the way, I kind of want to dive into the recommendations and takeaways. And so 3 takeaways I had from this analysis was I want to look at and analyze campaign 916 to further understand why it was more effective than the other campaigns. Like we saw, I had a 21.2 conversion rate, and the other 2 campaigns weren't even close. Second, I would like to find a table to pair the Facebook numerical interest value with its associated character value. So if I go back to the data dictionary, we had a column for FB campaign ID, which is just how Facebook tracks each campaign. We had a column for interest, as noted by Facebook. And we had a spend column, which was the amount paid by company XYZ to Facebook to show that ad. And so I'd like to do the similar stuff I did for campaign ID to the Facebook campaign ID. And lastly, I'd love to create a linear regression model that incorporates the amount spent per ad and clicks for each campaign. All right, so to recap, did we meet the primary and secondary goals of this project? Let's see. So primary goal, identify the social media campaign that effectively converted the most customers. We did that. Secondary goals, measure the performance of ads and campaigns. We did that in the frequency table section and also the visualization section, where we used bar charts and column charts. Another secondary goal, to visualize nominal trends in regard to each campaign by age group. Again, we did that in the visualization section. Calculate descriptive KPIs and measure success of each campaign. We did that as well, where we calculated the click-through rate, the cost per click, and the conversion rate, among other things. And lastly, identify the correlative and non-correlative relationships between variables of interest. Again, we can check that one off. So all in all, we met each of the goals. I hope you guys learned a little bit about how I go about my R process and my R process for analytical projects. If you guys have any questions, feel free to share them in the comments. Like and subscribe, all that good stuff. And, look forward to making the second video. If you guys have any ideas, just let me know. I'll see you all later.